So again, this is on the top of page 34. Give me a second to finish writing that. All right, then the changes in the rocks due to metamorphism. Here is what can happen because of metamorphism. So remember, they get heat and pressure. So this is going to be called recrystallization of unmelted material. And that is a really silly phrase. And I'm going to explain that in 1 second. Some other changes that will happen is the density will increase, and that's because you're putting more pressure on it. So density goes up when you put pressure on it. And then 2 other things that can happen is foliation and banding. The recrystallization of unmelted material. Like I said, it's a weird phrase. And I do believe, did I ever talk to you guys about a Hershey bar before in this class? Okay, so it doesn't sound familiar then. So I like to relate metamorphic rocks to leaving a Hershey bar on my car seat in August. First of all, can you picture the Hershey bar before I leave it in the car?
Yeah.
So everybody, and I specifically picked a Hershey bar because each Hershey bar, like, and I'm talking about a full-size one. They have the individual rectangles, you know what I'm talking about? So it's a big rectangle and it's broken up into the little ones. And then on each little rectangle, it says Hershey. So now I want you to picture putting that unwrapped on my car seat in August. What's gonna happen to that Hershey bar? Now, what you guys all said melt, but will the chocolate melt? Like, will I be able to pour it out like a liquid? No. So it's not quite melting, hence the unmelted. So it's not quite melted, it's this unmelted thing. It turns gooey, mushy, where you could move it around into whatever shape you wanted to. So now we have that Hershey bar. And then it's nighttime. What's going to happen to that Hershey bar at night now? It's going to re-solidify, recrystallize. Now, will that Hershey bar look the same as it did before, like I put it in my car? No, what's going to be different about it? The shape. So you know those perfect rectangles it had all over it before? They're not going to be perfect, but are you going to be able to tell they used to be there? Probably, as long as not too much happened to that chocolate bar, you still might be able to get the idea that there was some rectangle. So it might still kind of resemble what it used to look like, but it's not going to be the same. It's going to be changed. So that's what this means, the recrystallization of unmelted material. That's the Hershey bar, the not quite gooey, or the not quite melted, but the gooey Hershey's. And then it recrystallizes, it gets solid again. That's just like a metamorphic rock. Metamorphic rocks don't melt. They get gooey and then change. So there, that was that part. So the next bullet, so by the way, no, we already talked about that the other day. Regional metamorphism. So this is about halfway down page 34. This occurs when large areas of rock undergo intense heat and pressure. Or it occurs when large areas of rocks are under intense area. Oh my gosh, can't read. Occurs when large area of rocks are under intense heat and pressure. So it's a huge area. It happens when mountains are built. So there's a lot of pressure on rocks when two plates come together, and those rocks are going to undergo all those changes we just talked about. So this is going to be a whole area. This is what happens anytime a mountain is built. So all mountains are typically going to be metamorphic rocks. So the Adirondacks, for example, are all metamorphic rocks because when those two plates came together, it put all those rocks under a lot of heat and pressure and made all of those rocks into metamorphic rocks. All right, the next one is contact. This just occurs when hot molten rock comes into contact, meaning it touches the rock around it. What? We'll be back to the recording. Fire Joe. Okay, out and into the right. could have been a lot worse. Oh, the light's still flashing. All right, so when you come back in, we were just writing down contact metamorphism. So start writing again. And we'll talk about that. That's only going to be slightly annoying. Don't look at it. It'll hurt your eyes. John, I said don't look at it.
You can't say that in the.
So contact metamorphism occurs when molten rock comes in contact with the surrounding rock. The heat will alter the rock it touches. Oh, I do like it without the sound of the heater going in the background, though. Was that? I was comfortable. Oh, there we go. So with contact metamorphism, this is only a small area, just whatever area touches the rock it's next to. This is kind of important concept though. So Michael, do you mind pretending you're a pile of limestone right now? Michael's gonna pretend he's a pile of limestone. Hey, by the way, what kind of rock is limestone? It's sedimentary. It is a clastic. I think that's what you were getting at. So it is, when I say kind of rock, that means igneous, sedimentary, or metamorphic. So limestone is in the sedimentary rock term. So Michael's going to be a pile of limestone and I'm going to be hot lava. So what's going to happen is I'm going to touch his shoulder because I'm just like burrowing my way through the ground and I end up just bumping into his shoulder. What happens to Michael's shoulder? It alters. Perfect answer. It happens when I come in contact with him. His shoulder's going to alter. Now, in real life, if hot lava touched a human, it's going to burn it. The same idea is true with rocks. They get burned or changed or altered. So he was limestone and he got changed into a new metamorphic rock. Hey, why don't you guys check your reference table? What rock is his shoulder now? So he was limestone and he got touched by hot lava and turned into a new rock. Patty, which rock does he turn into? It is marble, and you should have looked at your reference table because I told you to. It's down the comment section. If you read down the comment section for all of them, and when you get to marble, it says it's a metamorphism of limestone or dolostone. So that means when limestone gets touched by hot lava, it'll turn into marble. And that's contact metamorphism for you. Now, what we're going to do here, I don't need you to write all of this. But what I'd like you to do is kind of just take a look at the picture. Now, remember when I told you didn't have to know about these things over here? Well, these are those. So you can see the bricks. The bricks are the limestones. That was Michael. And this stuff right here, it is labeled basalt, but this was hot lava. So we have hot lava that touched limestone. And where it's touching it, just like when I touched his shoulder, that little area will get burned or changed into marble. Again, you don't need to write that. The last couple of bullets there on the top of page 35. So metamorphic rocks, we've already covered this. They get classified by whether they're foliated or non-foliated, and then whether they have banding. And the last couple of things we need to do here for metamorphic rocks will include degree of metamorphism. Now, before we start the notes there, have you guys ever heard of first, second, and third degree burns?
Yeah.
Do you know what that means or what it's talking about?
How bad the burn?
It's basically how bad the burn is or how much it changes. I also like to relate it to toasting a marshmallow. First degree burn is actually just a bad sunburn you can get it by other ways, but it's basically a bad sunburn. It's what most of us have probably experienced with a burn, where you burn yourself, it hurts, it changes it a little, but you heal. Second degree burn, it's going to be a pretty significant burn, but again, you're going to be okay. Like it might leave a scar, like I burned myself on the oven, I got a scar right here.
That would be when you get like a little toast on the marshmallow.
Yeah, so now we're not just a little brown golden marshmallow, but it's getting a little bit charred.
Now third degree. That's
Third degree is when you're like my daughter, you light that sucker on fire
Yeah.
and you just eat the whole, like she practically eats it flaming. Third degree burns, that person's skin is going to be severely altered, almost unrecognizable. Not you guys, that was lunch. Same is true with metamorphism. If you have a first degree metamorphism or a low grade metamorphism, that's just going to mean it's changed just a little bit. And I have two examples for that. I'm actually going to show up here first. This is shale. So and it's kind of hard to see here, but we've got shale. That's a sedimentary rock. I'm going to give it some heat and pressure and it's going to turn into slate. And I know you can't see much difference on the screen because there isn't much different. If you were to hold these two, this one's a little heavier because it's a little more dense. You can see that the layers are a little more compacted. So first degree or low degree change, not much difference. But when we get to a high grade metamorphism, that's when we take a rock like this piece of granite where you can see the nice individual crystals, and it turns into this, which again, you can kind of see they're related. They're the same color. You can see the pattern. Really what happened is each individual crystal squished and lined up. This is the mineral gneiss, or the metamorphic rock gneiss. So this is a high grade of metamorphism. Huge change compared to the low grade where there was barely any change. So let's go ahead and write that in. Degree of metamorphism. So it can be a small alteration to major changes depending on the amount of heat and pressure. And we got two more slides and that's it for the notes. So the next slide is just a parent material. It's what the rock used to be before it was changed. For example, Michael was a pile of limestone and then he changed into marble. So limestone is what it used to be. It was the parent. And then to finish up those notes, you can add this: the deeper underground, the more heat and pressure, the greater the change. So shale is just changed a little bit from its parent. Phyllite and schist are changed a little bit more, and then gneiss has a major change. No, still not you guys. So when you're done here, we're going to actually flip over and continue going over the notes, the ones that we are not notes, going over the homework, page 28. Everybody good with the notes? Okay. So because of the fire drill, we're kind of going to have to go through the homework pretty quick. So I'm going to just, let's see, I'll just go with just the answers first. And then if you have anything that you want me to go over, hopefully we have time. So number one, the answer would have been limestone and bituminous coal. Number two, composition. So check your work, guys. Number three, limestone. Number four, the sedimentary rock that may bubble with when HCl is placed on it. Guys, remember HCl is an acid. So the only time we talked about acids and bubbling was when we talked about minerals. So if you read down the distinguishing characteristics, bubbles with acid is calcite. So calcite will bubble with acid, but we wanted the name of a sedimentary rock. If I read down the composition, limestone is made out of calcite. So limestone is the one that will bubble with acid. Why? Because it's made out of calcite. So number four is limestone. And why? Because it's made out of calcite. Number five is coal. Number six is rock salt. Seven is carbon. 8, grain size. 9, breccia. 10, siltstone. 11, less than 0.0004 centimeters. Number 12, 0.006 to 0.2. Number 13, rock salt, rock gypsum, dolostone. If you had limestone in there too, that wouldn't have been wrong. 14 is limestone and bituminous coal. 15, slate. 16, conglomerate. 17, limestone. 18, sandstone. 19, rock gypsum. 20, dolostone. 21, bioclastic. 22, inorganic. 23, crystalline. Sedimentary rocks form near the surface and straight out of our notes. That's because that's where the weathering, erosion, and biological activity happen. Number 25 told you to look at the generalized bedrock geology of New York State in the Earth Science Reference Table, page 3. What rock type is most abundant? So we looked at this chart for latitude and longitude before. I told you to kind of ignore the background stuff. But you can see the background stuff matches up with types of rocks down here. So the dashes, the diagonal dashes, the black, the polka dots, the stripes, the diagonal stripes, and the other diagonal stripes all represent sedimentary rocks. If you look up on the map, this whole section, everything here at least, and a bunch of stuff over here is all that symbol. So most of New York State is made out of sedimentary rocks. Only the Adirondack region and a little bit over here in the Hudson Highlands are metamorphic. So the first 25 is sedimentary. The second 25 says, why are they fossils only in sedimentary rocks? And that's because the formation of the other rock types would destroy them. And how do sedimentary rocks form? They form by deposition, burial, and compaction of sediments. That's as far as I got with my other class. Do anybody have any questions on those particular ones? I know I didn't give you much time to go over them. But I'm guessing if you did them, you probably did them correctly. So there's no new homework tonight. We'll pick up finishing going over the homework on Monday, but we're just about done with the chapter. So expect a test early to mid next week.